shut the door. So day 2 for section 4.4 notes. We are looking at doing a phase shift today. Okay, in other words, a horizontal shift, left or right. There is another shift that we can do. We can vertically shift it. We'll tackle that in our next notes. So what was the period for sine and cosine? 2 pi. And when did that change? When b was not 1? Okay. And so how did we find the new period? Okay. So we've got 2 pi divided by b to figure out our period. And sine curves normally start where? At 0, and cosine curves start at 1. Okay. So if you look at the first graph here, we have both a sine curve and a cosine curve. Can you picture, for example, moving the red curve to match the blue curve? Is there a way you could shift it left or right to get them to line up? What could we do? We could take the red curve and shift it to the left to get it to line up. Easiest thing is to find a point maybe on an axis and look at where we would have to move to. Okay? So how far do we have to shift it? Half pi? Okay. So it says sine and cosines are complementary functions or co-functions of each other. They only differ by a phase shift of pi over 2. Write the cosine function as a phase shift of the sine function. So that means we want cosine to be written as something that we've done to our sine curve. Okay? And we need to do some kind of phase shift. So going back to our pictures, if we are starting with the sine curve and we want to convert it into the cosine curve, the red one has to move, we said, left pi over 2. How do we show that in our function, that it's going to go left? Yes, we have a plus sign. So if we do a plus pi over 2, we're actually taking that graph and we're shifting it left pi over 2. Okay? Now, we could do the reverse. We could start with the blue curve and say, how do we get it to match the red curve? All right? So we want to write the sine function as some kind of phase shift of cosine. And we said the phase shift is pi over 2, but which way do we have to move it now? If we want to start with the cosine curve, which is our blue one, now we have to move it to the right pi over 2 to get it to match. So what sign? A minus. Yep. Okay, so remember yesterday when I said both sines and cosines are called sinusoids? It's because we can just always get a cosine curve from a sine curve. It's just a simple phase shift. Okay? All right, so yesterday we talked about A. What does A do? The absolute value of A is your amplitude. Okay? So if there's a number in front, let's say it's -5, what would that mean? Okay, so we're stretching it vertically 5, which means our curve is going to bounce between a +5 and a -5. All right, so that would be our range if we were asked for the range of our graph, right? -5 to 5. But because it was -5, we have to flip it over the x-axis. Okay. What did B do to my equation when there was a number there?
Shorter or longer?
Yeah, that was that horizontal stretcher compression. What happened if, let's say, B was 2? It actually compresses it, right? We get 2 cycles in the same span of 2 pi instead of 1. Okay? How do we find that new period? Okay, so now we're all going to start answering questions, right? Not just Sam? Okay. 2 pi divided by b gets us the new period. Today's focus is going to be on our h value. We'll still incorporate a's and b's in there, but we're going to look at how does that h change my equation? What does it change on my graph? So h is called the phase shift, or your horizontal shift. And we said if it was a positive value, we shift to the left. If it's a negative value, we shift to the right. The tricky part is when there's a b term other than a 1, in order to say what your phase shift is, that b has to be factored out. Notice these parentheses here. Okay, we've factored b out of it. Then you can say this is your phase shift. But if b hasn't been factored out yet, this whatever's in this h position would not be your phase shift yet. Okay, you got to factor the b out. And I'm going to show you a way to kind of get around that. When we graphed sines and cosines yesterday, we had 5 critical points, right? For a sine curve, we started at 0, then we went high, then back to 0, then we went low, then back to 0. Okay? So there were 5 dots that we were plotting, which means we had to have 5 tick marks labeled so we knew what we were doing. In order to figure out the new period and what those 5 critical points should be, we are going to use this. We're going to take everything that comes after the sine or cosine word, all right, that b and the x minus h, we're going to take that whole piece, and we're going to say, normally, we started at 0, and we finished at 2 pi. What is all this stuff in the middle going to do? Is it going to change the period? Is it going to move it left or right? What's it going to do to my starting and ending points? Okay, so let's start with this first example here. We've got f of x being 3 sine of the quantity x minus pi over 2. Okay, so if we were analyzing this, we would say the amplitude is 3, so we've done a vertical stretch. Have we changed the period at all? No. In this case, b is 1. Okay, so period would be 2 pi again. And what did we do yesterday to figure out what the increments would be? We chunked it into 4 parts, right? So we took 2 pi divided by 4 and said each one's going to be pi over 2. Okay? So let's look at what if b wasn't a 1. All right, I'm going to show you the same process for all of them, whether b is 1 or not. We take what's inside here, the x minus pi over 2, and we say normally we start at 0 and we end at 2 pi. And let's solve that for x. All right, so what do we do to get x alone? Add pi over 2 to both sides. So adding pi over 2 here and adding it on the right side. So if we're adding a half pi, we need to think of this 2 pi in terms of halves. 2 pi is the same as how many halves? So right now we have 4 pi here, or sorry, 4 halves pi, and we're adding another half pi. So we should get 5 halves pi. We're going to be doing lots of fraction work in the next few days. If that's a hard thing for you, make sure you're coming in and getting help. Okay, so we are going to start at pi over 2, and we're going to end at 5 pi over 2. How big of a span is that? If we start at 1 half pi and we end at 5 half pi's, we've really gone 2 pi, right? Which is what we said the period was. Okay, so that fits. We've got the right period. All we've done is instead of starting at 0 and 2 pi, we've shifted everything to the right pi over 2. Okay, so our phase shift here, we're going pi over 2 to the right. Okay, and we'll actually do some graphing of these in a few minutes. Right now we're just working on the math part of it. All right, so our next example says construct a sinusoid, and remember that could be sine or cosine. Usually there's a more logical one to pick, and we'll talk about why we would pick one over the other. But it says construct a sinusoid that has a period of pi over 5 and an amplitude of 6, and we want it to go through the point 2, 0. Okay? So because we want it to be on the x-axis, 2, 0 is a point on the x-axis, Which trig function starts on the x-axis? Sine. So when I said logical choice, our logical choice would be to start with a sine curve because we know that sine starts at the point 0, 0, right? And so if we want it to end up going through the point 2, 0, we could simply shift everything to the right 2. And then we've made sure that it's going to hit that point. Okay? So we're going to start with a sine curve. And what are the things that we know? So there is a b value, right? Because the period changed from 2 pi. So we have to figure out our b term. And we're told the amplitude is 6. Okay? So we know a has to be 6 or negative 6. It's easier just to use the positive version. Okay? So right away I could start out and say my equation is going to be 6 sine of something. Okay? And now I have to figure out, okay, what is my b term? What is my phase shift? That's going to make all this happen. All right, so let's go back over here. We have a period of pi over 5. Normally, period is 2 pi divided by b. And it's usually the absolute value of b, right? We don't worry about the sign of that. We want that to be pi over 5. So can we solve and figure out what b has to be? Sure. What happens to the 2 pi's? We got a pi on each side. They're going to cancel out. So really we're saying 2 over the absolute value of b has to be 1 over 5. And if we cross multiply, b has to be 10. So the absolute value of b is 10, which means we could use a positive or a negative. But again, the easier choice is the positive one. What would a negative b do to my graph? Yeah, remember when that b term was negative, it flips over the y-axis instead of over the x-axis? So we don't want to get that messy. They're just saying, give me a function that will work, that will fit this criteria. Okay? Either one would be fine, but again, the easier one is the positive version. Okay? So now we've got y equals 6 sine of 10x. Yes? Because we just figured out our b term has to be a 10. Now, how do we deal with the phase shift? We are told that we wanted to shift it 2 to the right. And when we look at putting that phase shift into my function, the 10 had to be factored out. Yes, that b term was out. It looked like this. Yes? Okay. So we can put the 2 in here. It's going to shift it to the right 2, which means we want what sign? A minus sign. Okay. Now, we can leave it like that. That's fine. We've got the change in period here of a 10. We've got shifting to the right 2. If we distributed the 10, we could also show it like this. Okay? Now, I want you to think about this for a sec. If I look at it this way and say, well, what if this one's saying go 2 to the right, this one's saying go 20 to the right? But if I go 20 to the right and then I compress it, right, that 10 value is going to compress it to 1/10 of its size. So instead of being a 20, it moves me to 2. Okay, you see how that's working? So in this form, I have to have it like this to say my phase shift equals 2. I would not say I have a phase shift of 20. Okay, I have a phase shift of 2. My whole graph's been compressed.
Would you need the phase shift in this case though? Because it just says that the point goes through 2, 0, not that it starts at 2, 0.
But you have to force it to go through that point. And a normal sine curve, if you start here, are you going to force it to go through 2, 0? Where does it hit 0 again? It's here, then high, then back here at pi. Pi is 3.14. We want it to hit at 2. Does that make sense?
Yes.
Okay. All right, so let's try a few where we actually graph them. This is the fun part, right? I know that's what you're all thinking. This is the fun part. Okay, it says determine the amplitude, period, and phase shift for each equation and graph it. It does not say to graph 2 full periods, so we are going to just graph 1. Could you repeat what you've graphed a second time if you had to graph 2 full periods?
Yes.
Yes. Okay. So analyzing our first one here, amplitude is 1/2. Now instead of trying to scrunch this down, because I'm going to have tick marks labeled here, let's make our y scale go by halves. All right. So I'm going to make the second mark a 1. Does that make sense? So that I still have a little space there to put a half dot in. Okay. What about b? b is 1 in this case, which means the period is 2 pi again. And when we have a normal period of 2 pi, our increments are, everybody okay with that? Pi over 2s? Take 2 pi divided by 4. Our increments are going to be in pi over 2s. Okay. I'm going to show you the same process for all of them. So it's not a case of, oh, b is 1, I do it this way. b is 2, I have to do it a different way. I'm going to take this x plus pi over 2 and say, normally we start at 0 and we end at 2 pi. Where am I going to start and end now? Okay, I'm going to subtract pi over 2 to that side. I'm going to subtract a pi over 2 on this side. What does that mean? I'm at 3 halves, right? 2 pi is 4 halves. I'm taking 1 away. I'm at 3 halves. Is that still a distance of 2 pi? We okay with that? All right. Now, this one works out pretty nice because we are shifting which way? We're shifting left pi over 2. Okay, so I could say my phase shift equals negative pi over 2. I went left to negative pi over 2. But my increments are in pi over 2, so it makes working out the tick marks really nice and easy since everything is in terms of halves. Okay. I am going to spread this out a little bit. If you go by every tick mark, it's get really hard to label them. It gets very scrunched. So let's call this negative pi over 2. All right. So that's going to be my starting point. This will be the next tick mark at 0. If I add another pi over 2, I land here. Add another pi over 2, I land here. Add another pi over 2, I land here. And that's where I'm supposed to stop. Have I started and stopped at negative pi over 2 and 3 pi over 2? Is that space cut into 4 equal chunks? Okay, if you look at it, 2 squares here, 2 squares, 2 squares, 2 squares. I got 4 equal chunks. Okay, now let's get our dots plotted. It's a cosine curve, so it normally starts high. What is high in this case? 1/2. So instead of starting at 1, we have done a vertical compression, right? We're only going to start at 1/2. But notice that we're starting over here instead of on the axis, right? Because we've shifted it to the left. My next tick mark is going to put me at what y level? At 0. My next tick mark puts me at my low point, which in this case is negative 1/2. And then I'm back up at 0, and then I am back to my high point of 1/2. All right, draw in your nice smooth cosine curve. And that would be 1 period. Okay? All right. At your tables, talk very briefly. You don't have to write anything down, just talk quickly. What do you notice in this next equation? What's going to happen to my graph? All right, what do we come up with? It's going to reflect. Okay, we know we have a reflection over the x-axis. We're going to have to remember that when we get to the point where we actually start plotting points. So we're going to reflect over the x-axis. The amplitude is 1/2. Okay, so once again, I'm going to go by halves here so that I can spread it out a little bit. How about the period? Has that changed? No? Okay, so period is still 2 pi. Okay, and so our increments when we do our graph are going to go by what? Pi over 2's. Okay. Now let's look at where do we start and end. Normally it is 0 and 2 pi. But our term here in the middle is x plus pi over 4. So what happens? We're going to subtract pi over 4. If we subtract 1/4 from 2 pi, what do we end up with? 7/4, right? Because 2 pi would be 8/4. We're subtracting 1, so we have 7/4. So to go from -1/4 to a positive 7/4, is that still a span of 2 pi? Okay. So how are we going to mark this on our grid? In the previous one, we went each tick mark, or each square really was 1/4 pi, right? Because we went every other one and labeled them halves. So let's do the same thing here. So we're going to start here at negative pi over 4. 1 square to the left. And then we are counting up by what? Our increments are going in pi over 2's, which is 2/4. Yes? So we're going to go 2 squares to get to our next tick mark. Okay. So 2 squares would put us here at what? Pi over 4. 2 more squares, or adding 2/4 to that, puts us at 3/4. Adding 2 more fourths puts me at 5/4. And adding 2 more fourths puts me at 7/4. So did I start at -1/4 and end at 7/4? And is that 4 equal spaces? It's 5 labels, right? But we have a starting and an ending label, so it really breaks it up into 4 chunks. Are we okay with that? All right. So let's get our points on there. We have to remember to reflect it. It's a sine curve. Sine normally starts on the axis, right at 0. We have shifted it to the left pi over 4, so we're going to start here. And then normally we go high, but we're reflecting it, so we're going to go low instead. Yes? So from here, my next tick mark is going to be my low point of -1/2. Then I'm back to 0. Then I'm at my high point of 1/2 and back to 0. So we have a sine curve that's just been shifted which way? Left, how far? Okay, so my phase shift here would be negative pi over 4. I've moved it left that far. Questions on that one? All right, what do you notice about the next one? We have a B term, right? That's not 1. So now the period's going to change on top of everything else we've been doing. All right, let's go in order. 4 is what? Our amplitude. So we are going to stretch and bounce between -4 and 4. That would be the range for my graph. Okay, so I'll mark those on my grid. Period is normally 2 pi. We have to divide it by our B term of 2, which means the period is going to be 1 pi, right? So we've scrunched this horizontally, compressed it to half its size. What would my increments be then? I have to take that period of pi and split it into 4 equal chunks. So each one is going to go in a space of pi over 4. Okay. Let's look at where do we start and end. Normal is 0 to 2 pi. My expression inside, I'm going to take the whole thing. Because remember that pi over 3 that you see is not your phase shift, right? B hasn't been factored out of all of that yet. So we're going to take the whole thing, 2x minus pi over 3, and figure out where we actually have to move to. How do we do that? What are we going to do? Add the pi over 3's, okay? So we're going to get pi over 3 is less than or equal to 2x, which is less than or equal to what? 2 pi is 6/3. We're adding another third to it, so we're at 7/3. How do we get rid of the 2? Dividing by 2, which is the same as timesing by 1/2. So if we times both sides by 1/2, we get pi over 6 and 7 pi over 6. Is that still a span of 1 pi, which is what the period is supposed to be? From 1/6 to 7/6 would be 6/6. That's pi, okay? So our phase shift is really what? We really went to the right pi over 6, okay? Now, the tricky part with this is that we are starting at pi over 6, and my increments are in pi over 4's. Okay? So when we go to count this out, we just have to be a little more careful. We have to think in terms of fractions. So let's say we're starting here at pi over 6. I'm ending at 7 pi over 6. I know that. So I could get that mark drawn in. All right, so this is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6 would be here. Okay? How many squares is that? How many squares did I go by? 6, right? 6, 6, that's pi. Okay? So can I cut 6 squares in half? Yes. All right, so find your half mark. We're going to have a tick mark there. Well, we're counting by sixths, so this would be 1, 6, 2, 6, 3, 6, 4 sixths, which would reduce to 2/3. So this mark would be 2/3 pi. Now here's the trickier part. Now you've got 3 squares that you have to cut in half. Okay, so we're going to have a mark here, and we're going to have a mark here. Yes? Okay. Well, what does a half of a square mean? How wide is that? If 1 square is 1/6 of pi, it would be a 12th. So let's count in 12ths so we can see what that mark should be. 1/6 is 2/12ths, okay? And each half of a square is another 12th, right? So we're at 2/12ths, 3/12ths, 4/12ths, 5/12ths. We okay with that? Let's try to make that actually look like 5/12ths. Okay, doing the same thing. We are, let's start at our 2/3. 2/3 is how many twelfths? 8/12ths. So we're at 8/12ths, and we have to go 3 more twelfths. So we're at 11/12ths. If we went 3 more twelfths, that would put me at 14/12ths. Is that where I stop? 7/6 is the same as 14/12ths. So what I'm really doing is I'm taking my starting value here of pi over 6, and I'm saying each time I have to add this increment of pi over 4. But I need to think in terms of a common denominator. So if I think in terms of twelfths, this is saying I have 2 twelfths and I'm adding 3 twelfths. That puts me at 5 twelfths, which was my next increment. And then I add another 3 twelfths, and that puts me at 8 twelfths, which was my 2/3. And then I add another 3 twelfths, and I'm at 11 twelfths. Does that make sense? I'm just going to keep adding that fraction to my marks. All right, let's get our graph drawn. It is a cosine curve. Does cosine start on the axis or high? Cosine starts high. In this case, high is 4 because of our amplitude. All right, and we're starting at the first tick mark here of pi over 6. So my first dot should be right there. Okay, my next dot comes down to 0, and that's going to be at my next tick mark. My next dot goes to my low point, which in this case would be -4. And then I'm back at 0, and then I'm back at my high point. Okay? All right. Let's try one more. Okay, analyzing this one. What can you tell me about amplitude? Okay. Does the period change? Is its period 2 pi? No. Okay. Period is going to be 2 pi divided by 2, or 1 pi again, which means increments are pi over 4s. Okay. Let's look at our starting and stopping. We need 2x minus 2 pi over 3. Normally we go from 0 to 2 pi. All right, what do we need to do? Okay, add 2 pi over 3 to both sides. Now, we're adding thirds, right? So think in terms of thirds. 2 pi is 6/3, and we're adding 2 more thirds, so now we're at 8/3. Okay, and now we have to divide by 2. What happens? What's 2/3 divided by 2, or times 1/2? Half of 2/3 would be, what's half of 2? 1. So half of 2/3 would be 1/3. What's half of 8/3? 4/3. Okay. Going from 1/3 to 4/3, is that 1 pi, which is what our period is supposed to be? Yep. Okay. Now, before we mark anything on our graph, let's look at what our critical labels are going to be, those 5 marks that we need to put in. Okay. We are starting at pi over 3, and each increment has to go up by pi over 4s. Okay. We want to think in terms of a common denominator, so what would we use? 12s? So 1/3 is how many twelfths? Okay, so I have 4 twelfths, and I'm adding 3 twelfths. So my next increment is going to be at 7 twelfths, okay? So I'm going to start here or here at 1/3. I'm going to end my next, or sorry, I'm not going to end. My next tick mark would be at 7 twelfths. If I add another 3 twelfths, what do I get? 10 twelfths, but that could reduce to 5, 6. So that's my next mark. I'm going to add another 3 twelfths. So I had 10 twelfths, and I'm adding 3 more, so now I'm at 13 twelfths. Okay, and then I'm going to add 3 more, and I'm at 16 twelfths. What would that reduce to? 4/3. All right, and that's where I was supposed to end, right? So I've got all the labels that I need for my tick marks. We just have to figure out how to space them on our graph. So can we go by the same thing we used on the other one? Go by sixths? So a 12th would be halfway through a square? That work? Okay. So our first mark was what? Pi over 3, which is 2/6. So we're going to start here. And now we have to add 3/12 to that, which is how many squares? If one square is a sixth or 2/12, how many squares are we going? 1.5 squares? Okay, so 1.5 squares over, and that's going to be labeled 7/12. 1.5 squares over, and that's going to be labeled 5/6. One and a half squares over, and we're going to label that 13/12. And then 1.5 squares over, and we get to 4/3. Okay. Amplitude is 4. And it is a sine curve. Sine starts where? Starts on the axis, right? We're going to start at our first tick mark here of pi over 3. And then, did we do a reflection on this one? No. So from 0 we go to our high point, which is 4. It's going to be in the middle of a square there. Then we're back at 0. Then in the middle of a square we're down here at -4. And then back at 0. Okay. All right, so you are working on day 2. It starts with question 35. I don't think you have a lot of graphs, but I am going to give you a sheet of graph paper just because it might be helpful for you to visualize some things. You draw it out.